All right, so now that let's look at polynomial inequalities. Polynomial inequalities are of degree 2 or higher, so it might have an x squared, or an x to the third, or an x to the fourth, or higher term. If you look at number 1, can you see that if I multiplied that all out, there would be an x to the third term? So this is a cubic inequality. Now, if they're linear, like the ones you've been doing with the have or do not have absolute value bars, don't change your method. But if you go x squared or higher, then you need to follow the directions listed in black above. You've got to pull all the terms to one side of the inequality so that you have a 0 on the opposite side. You completely factor if possible. Once you factor, you identify the critical values easily. If you can't factor, you still have to identify critical values. It just might be more complicated to do so, and we'll talk about that. You must use a sign chart, and you will answer in interval notation. Now, on number 1, I've taken a lot of the hard part out of the problem because I've already factored it. So when you factor it, you can easily see that your critical values, which I'll abbreviate as CVs, are at x equals, from the factor of x, 0, from the factor of x plus 3, negative 3, and from the factor of x minus 4, positive 4. So if I had said x times x plus 3 times x minus 4 equals 0, you would have said those were the three x-intercepts. But when they're inequalities, we're going to call them critical values. You will learn more about why we call them critical values in calculus. For now, I'm just going to borrow that terminology so that next year it feels familiar to you. All right, once you have your critical values, you're going to make a sign chart. And on the sign chart, you will put the three critical values in order as they would appear on the number line. So 0 would be in the middle, negative 3 would be on the left, and 4 would be on the right. So using these three critical values as dividers on your sign chart gives you 4 different sections on your number line. Please make this a chart, not just a number line. So draw the vertical dividing bars. Again, this is going to transition into calculus where there's a particular way you're going to need to show your work. So we'll practice good work habits now. Now, the next thing for you to do is to pick a test value in each section of the sign chart. So I need, in this leftmost section, something less than negative 3. Well, I'm going to go negative 10. And sometimes the bigger you can go with your numbers, the more extreme, it'll make the sign chart actually go more quickly for you. So between 0 and negative 3, let me pick negative 1. Between 0 and 4, I'll pick 2. And larger than 4, I'll pick 56. Now, larger than 4, you could have picked 5. You could have picked 10. Anything that's actually larger than 4 is going to give you the same result. So test values, there's always multiple choices there, okay? So now what we do is we plug in to the factored form. So if I sink negative 10 into x, my first little bitty factor turns out negative. When I sink negative 10 into x plus 3, that would give me negative 7, which is negative. When I sink negative 10 into x minus 4, that would give me negative 14, which is negative. And if I multiply out 3 negatives, my result's negative. So I'm going to make the result sign really big. When I plug negative 1 into x, I get a negative. When I plug negative 1 into x plus 3, I get positive 2, so I get a positive. When I plug negative 1 into x minus 4, I get a negative 5, which is negative. That didn't write where I meant for it to, so let's try that again. So multiplying out 2 negatives gives you a big positive result. Plugging 2 into x is positive. Plugging 2 into x plus 3 is positive 5. Plugging 2 into x minus 4 is negative 2. So when I plug in 56, can you say 56? 56 plus 3, 56 minus 4. So the beauty of a sign chart is you don't actually have to give me numbers, which is more time consuming. You can quickly analyze signs, which is much faster and is very powerful as you move through this class and in calculus. So sign charts are a thing of beauty, guys. So here we go. What I'm going to do is say, let's color the number line for our results. So the first thing I notice is we've got greater than or equal to 0. So I'm going to color all closed circles. Now, greater than 0 means positive. So I'm going to color the number line where I got positive results. Now I've got my number line colored. It's easy for me to go to interval notation and say, well, that's just bracket -3 to 0 bracket, union bracket 4 to infinity. So let's do the next one. Now again, I've kind of taken it easy on you because I've already factored it for you. A lot of times the factoring is the hardest part. Once you hit the sign chart part of the problem, you ought to recognize, man, you can hustle at that point. So here my critical values are at x equals 0, x equals 1, and x equals -3. Don't worry about saying that this is a single root and that's a double root. That would be true if you were answering something equal to 0. But if it's less than 0 or greater than 0, critical values, you don't need to worry about saying single, double, triple root. Okay? So let's do the number line. And 0 is going to go in the middle, so put it over one of your dividing bars. Yes, I just emphasized use bars. Don't just make it a number line. It's a sign chart, so you got to have the columns on the chart distinctly labeled, okay? So I'm going to sweep through and pick test values. So again, I'll pick -10, -1, 1/2, and +10. So I'm going to start picking or plugging in. So notice if I say, well, what is -10 squared? It's +100. What is -10 minus 1? It's clearly negative. What is -10 plus 3? Well, it's -7, but when I square it, it's positive. So I get 1 negative, which is my big result. -1 squared is positive. -1 minus 1 is negative. And -1 plus 3 squared is going to be positive. Uh-oh, my sign chart didn't change signs. That's right. Don't assume they alternate. A lot of them do, but not all of them. So actually take time with each sign chart. 1/2 squared is positive. 1/2 minus 1 is negative. 1/2 plus 3 quantity squared is positive. So remember, if it's squared, it's going to be positive, period. 10 squared, 10 minus 1, 10 plus 3 squared. So I finally got a change in sign. Now, the next thing I notice is that it's less than 0, not less than or equal to 0. So the first thing I'm going to do is use open circles. I also notice that less than 0 means negative, so negative results. Well, when I look at the number line, I see 3 different intervals, so I need to make sure that I've got 3 different intervals accounted for. So to the left of -3 is -infinity to -3, parentheses, union, -3 to 0, union 0 to 1. So your intervals should always read left to right, okay? Don't mix them up. The order matters. Guys, just one note. If it had been less than or equal to 0, where I would have colored in the -3, the 0, and the 1, that would have not been 3 separate intervals. It would have been one solid interval, and my answer would have been from -infinity to 1 bracket. So just wanted to make a note of that. Now, on number 3, the goal is to get you to think about how to deal with a leading negative. There are 2 ways to do it. I can either deal with the leading negative by factoring it out as a GCF, or I can multiply the whole inequality by a -1. I'm going to bet that several of you might like that choice. So let's start there. If you multiply everything by a -1, we wind up with x squared minus 5x. I'm multiplying by a negative, so flip the inequality, and -4. Then I have x squared minus 5x plus 4 is less than 0. Well, now I'm just going to try to factor. So let's see, x squared has to be x times x. And if I use 4 and 1, I can get 5. So it looks like it needs to be -4 and -1 multiplies out to +4. And -4 and -1 adds up to -5. So that means my critical values are at x equals 1 and 4. So I'm going to do a quick sign chart. So 2 divider bars, 1 and 4. And let's see here, I'm going to pick test values. So if you can pick 0, 0 is always a fast one. 2, and then 17. And again, I could have picked 5 and been vanilla, but sometimes it's easier if you go big. So I'm going to plug in 0 minus 4 is negative, 0 minus 1 is negative, that's a big positive result. 2 minus 4 is negative, 2 minus 1 is positive, that's a big negative result. 17 minus 4 is positive, 17 minus 1 is positive, that's a big positive result. So if I look at it, I see that because it's less than, not less than or equal to, I've got open circles. Less than means negative, not positive. So my answer is 1 to 4. Now I'm going to show you how to deal with the negative the other way, because occasionally you won't be able to do anything but deal with it that way. I'm thinking in terms of where you're headed with calculus. So if I had kept it -x squared plus 5x, I would have gone ahead and pulled the -4 is greater than 0. Factor out a negative, then I want to have x squared minus 5x plus 4 is greater than 0. Factor it. Now I'm going to zip through this pretty quickly, because I know you're going to get more antsy with videos. I'm still going to have 1 and 4 on my number line. And I won't go through all this, but I want you to see part of it. So what if I just show you how it works out in the middle? So if I test 2 in the middle this time, you've got to realize you have 3 different signs to deal with. So this negative means negative. I'm going to try to put that where I meant for it to be. Negative is one of your signs, period. And then 2 minus 4 is negative, and then 2 minus 1 is positive, and your result is positive. And you might say, well, wait a minute, that doesn't match the sign chart before. No, it doesn't, but recognize, guys, that now you're looking for where you get a greater than 0. So where you get greater than 0 is where you get a positive result. So my result would still be 1 to 4. So your sign chart's going to be exactly opposite what we did first, but the resulting answer's the same. I'm going to bet most of you at this point would rather multiply through by the negative from the get-go like we did first. But what I did in black will be more pertinent to you in a couple of chapters. So just hold on to that thought. Now, on number 4, we're also talking about the same issue, but I'm going to use this as a way to show you a couple different things. Number 1, do not work with such a messy quadratic. So definitely clear the fractions. So I'm going to give you stuff that looks messy, and you need to tell me, oh, Miss Porter, good gosh, don't try to mess with me. I can make that look easier. If you want to be good at math, figure out how to take simple strategies even for difficult looking problems. And that's what we're going to work on all year long. All right, so I'm looking at this, and do you recognize what I recognize? this is not going to factor, because the only way that you can get factors of 27 are to use 1 and 27, or negative 1 and negative 27, or 3 and 9, or negative 3 and negative 9. None of those are going to give you a positive 10 in the middle. So what you're going to have to do is leave the inequality for just a minute and think about, if I ask you to solve the equation, what would you do to find the solutions for the equation? Well, your best bet, because 10x is even, is to complete the square. That's always going to be your fastest strategy. I just have to convince you of that, because right now you're probably all about the quadratic formula. Complete the squares faster. So half of 10 is 5, and I'm going to put that 5 here. And 5 squared is 25, and that's what I'm going to balance the equation with, and that gives you negative 2. Well, guys, that means x is going to equal negative 5 plus or minus the square root of negative 2, or negative 5 plus or minus the square root of 2i. All right, critical values must be real. So what this is telling you is that you got critical values that are not real, therefore there are no critical values. Okay? If there are no critical values, then you don't get different divisions on the number line. So you can test any x value. So I could draw my number line, but I don't have different divisions, so I just pick any x value. Well, what's your easiest test value? 0 if you can pick it. So plug 0 in to the inequality that's most clean. Well, do you see that 0 squared plus 10 times 0 plus 27 is positive 27? So if 0 delivers a positive answer, and you want the positives, that means the whole entire number line does it, okay? That means your answer would be negative infinity to infinity if you answer in interval notation. And that's the same thing as just saying all real numbers are solutions. All right, well, let me toy with this one a little bit, because I want to show you a couple of different things with this weirdo problem, okay? So I'm going to insert a page. So it's x squared plus 10x plus 27. Okay. So we had x squared plus 10x plus 27 is greater than 0. Let's make it less than 0 so you could see how this works. Well, you would still say it won't factor, so let me pause for a minute and find critical values another way. So I would go through the same thing and realize there are no critical values because the answers to the equation are non-real. Well, if you have no critical values, again, what that's telling you is that on the number line, you're only going to have one big division. You don't have separate divisions. So you can choose any test value. Choosing 0 is the easiest. Well, when you plug in 0, your answer for the expression turns out positive. I can't get that to write where I want it to write. But again, the problem is you wanted to know, where was this negative? Well, it didn't turn out negative. So there's no shading that you can do. And if there's no shading on the number line, that means your answer is no solution. So it doesn't matter what value of x you plug in, the expression will be positive, not negative. Okay? So I'm using the exact same numbers. I just want to show you weird, strange things that can happen to you. All right, I'm going to amend this one more time to show you what else weird can happen. So what if we look at x squared plus 10x minus 27 is greater than 0. So I'm gonna change that last sign. Well, it still won't factor. So you've still got to take a break and examine the related equation. Well, how is it going to be best to solve the equation? I'm still going to complete the square. So half of 10 is still 5. And when I square the 5, I get 25. And when I add 25, I get 52. Oh my goodness. I'm going to get two real answers this time, but they're going to be real messy. So I'm going to say x equals negative 5 plus or minus the square root of 52. If you know anything about playing cards, you know 52 is 4 times 13 because there's 4 suits and each suit of cards has 13. So you got 13 diamonds, 13 hearts, 13 clubs and spades. So if 52 is 4 times 13, I can write it as 2 square root 13. So guys, those are my critical values. You don't necessarily need to rewrite them. I just wanted to make it clear that solving the related equation gave me messy critical values. I do get critical values. Ugh. Well, guys, you still just do a sign chart. It's just going to be a messy sign chart. So let me tell you, you're going to make a number line still. And you're going to have two critical values, so two dividing bars. Negative 5 minus 2 square root 13 has to be lower than negative 5 plus 2 square root 13. Now, I'm going to suggest that you go big with this because people will get too hung up on what they're doing. Now, I know negative 2 square root 13 can't be all that big, so why don't I make this something like negative 100 and positive 100? I'm pretty dadgum sure that that negative 5 plus 2 square root 13 is nowhere as big as 100. So 100 is a quick and safe entry into the sign chart. Now, a lot of people do a quick knee-jerk reaction on this. What is between negative 5 plus a number and negative 5 minus a number? If you said 0, that was a knee-jerk reaction. You kind of got the right answer, but you spit out the wrong thing. Just negative 5. Negative 5 is right between them, where you're adding and subtracting 0 from it. Now, those are going to be much easier to plug into your inequality. Well, what inequality do you plug into? This one. So you're just going to have one single sign because you don't have multiple factors. You've just got the one big expression. So I know that negative 100 squared is a really, really big positive number. Minus 1,000 minus 27. I don't have to work real hard to figure out that that's going to still be positive. Same thing on the other end. If I plug in 100, 100 squared's really big and positive. Plus 1,000 minus 27 is definitely positive. Now let me slow down on the negative 5 because those numbers are more in the middle. So negative 5 squared would be 50. Plus 10 times negative 5 would be minus... hello. I'm sorry. I just did something boneheaded. Yes. I'm darn good at math, but I too make goofball errors. So, oops on that. So let's try that again. Negative 5 squared is 25, and then 10 times negative 5 is negative 50. So if you write it all down, do you quickly go, oh yeah, that's negative? I don't know it's negative what. That doesn't matter. I could figure it out clearly, but it's just, I just need to assess, yeah, that's negative, move on. Don't spend too much time on it. Now, the next piece is to remember you are looking for greater than 0. So open circle, greater than 0 means positive. All right, so now you can answer it. And I'm going to say, well, that's negative infinity all the way up to that really weird critical value. Union, the other weird critical value, all the way to infinity. So here's the good news. You're not going to see a whole lot of these. Most of them will factor where your critical values are nice and neat. Even if you do have to do these weird, messy ones, you can find ways of making your sign chart go pretty fast by choosing easy test values. The bad news is you are still going to have some, and you need to learn to deal with the adversity. I know, kind of a bummer, but I am confident that you can handle it. Now, number 5 looks bigger, but my guess is a bunch of you are going to be happier with it. So look at it. Everything's already on the left side with 0 on the right. That's a good thing. Do you recognize what to do with the 4 terms? Bingo! 4 terms ought to be telling you to group. So don't stick parentheses in there. You're not multiplying yet. If you want to set off what you're grouping, like underline the parts or do brackets or something. So I know that the first part factors into x squared times x plus 3. I'm going to drop the minus sign down to the center. 16 goes into 48, so I'm going to use it as my GCF. And remember, if this is x plus 3, again, it's not writing where I mean for it to be. This is also x plus 3. I'm going to double check. That gives me x cubed, check, plus 3x squared, check, minus 16x, check, minus 48. So I've factored it right so far. Now, you can do x plus 3, and then it would be times x squared minus 16. Guys, whenever you factor all the way. So I'm going to factor the difference of 2 squares. Now here's the dill pickle. Some of you all are going to be minimalists in your responses, which is fine as long as you know which steps are okay to cut and which steps are not. This step would be okay to cut because I know most of you all will see a difference of squares and immediately be able to factor it in your head. So I would be all right if you skip that step, but don't skip the next step because it's a critical step. So now I can see that my critical values are at x equals negative 3 and plus or minus 4. Why am I writing this statement that way? Because I'm getting you ready for calculus. Why would I do that? Because this is pre-calculus. My job's to get you ready for calculus. All right, so I need 3 divider bars on my number line. Bars, make a chart, not a number line. So negative 4 and then negative 3 and positive 4 would be the order. I'm going to pick some test values. So negative 51, negative 3.5, 0, if you can pick 0, do, and 77. I know that you also picked negative 51 and 77, didn't you? All right, so let's go ahead and insert negative 51 plus 3. Negative 51 plus 4, negative 51 minus 4, negative 3.5 plus 3, negative 3.5 plus 4 is positive, be careful there, negative 3.5 minus 4, positive, 0 plus 3, 0 plus 4, 0 minus 4, I love 0 because it's so fast, 77 plus 3, 77 plus 4, 77 minus 4. So guys, I'm hustling, but it's because I want you to realize you can hustle on these. Sign charts are awesome because they're super duper powerful, but they're also super duper fast. And we use sign charts throughout pre-calculus and calculus. They always work the same way, but they'll give us different results based on why we're using them in the different sorts of problems. So they're cool. So I'm seeing less than or equal to 0, so closed circles. Less than means negative, so I'm shading. All right, beat me. Can you rush ahead of me and write down the answer? I'm going to give you a 5-second head start. All right, that's it. Now I'm starting. All right. Give me a cheer if you got it right. I hope you did. So guys, I'm going to end this video here, and then you'll do one last video on rational inequalities, and then I know you're going to be worn out with inequalities, but this is such important information. It's probably the least familiar thing on this first chapter, so it's extremely important that you get it and that you ask questions if you feel fuzzy.